We are going to go ahead and finish the last three. I think I have my technical difficulties worked out. So in the last one here, number 3, we see zinc plus hydrochloric acid yields zinc chloride plus hydrogen gas. And that should look very familiar because that's the reaction we did last week in lab. How many moles of hydrogen, so that is showing me right there what I'm trying to get to is moles of hydrogen. So I'm going to go ahead and fill that in, are produced from the reaction of 3 moles of zinc. So that is our given, and since it's our given, that's what we're going to write down to start with. So how do we get from moles of zinc to moles of hydrogen? Well, we first have to get rid of moles of zinc, and to do that, we're going to drop those units down. And once we do that, we see mole over mole. And when you see mole over mole, that is showing you a mole ratio. And when we see a mole ratio, we know we have to look to the coefficients. Moles of zinc. When I look up here by balanced chemical reaction, I do not see a coefficient in front of the zinc, so I'm going to make the assumption that that is a 1. And find hydrogen right here. Again, no coefficient in front of it, so we again make the assumption that it's a 1. Moles of zinc. Mama. Good job. Moles of zinc cancels out, and you are left with 3 moles of hydrogen. Do you want to show my students what you did? We'll show them real quick. Okay, this is a perfect artwork by one Nora Lee Vaughn. There it is. Okay, now on to number 4. Here we have combustion. We see C3H8, which is actually propane, reacts with oxygen to produce 3 moles of carbon dioxide plus 4 moles of water. And the question is asking us how many moles of oxygen are necessary to react completely with 4 moles of propane. So please start by writing down what you're given, and in this situation, you are given 4 moles of propane. And guys, when you're writing these out, I cannot stress enough to you how important it is to write down the units, and not only the mole units, but what compound it represents.
I'm all done.
We're trying to get to
this is
moles
the one for me, Mom.
Of oxygen.
And this is the one.
So how do we get rid of moles of
Miss
propane?
Nicole.
We're going to drop those units down just like we've been doing. So now there's moles of propane. And once again, we see mole over mole, which is a mole ratio. So when you see that mole ratio, you're going to look to the chemical equation of the coefficients. When you find propane, we see that there's no coefficient located in front of it, so we make the assumption that it's a 1. Moles of O2, look to the coefficient. We see that there's 5 moles of O2 in this reaction. So moles are going to cancel out. 4 times 5 gives us 20 moles of oxygen would be produced. Okay. Questions? And on the last one, we have potassium phosphate plus aluminum nitrate yields potassium nitrate plus aluminum phosphate. How many moles of potassium nitrate, so again, that's my ending point, that's what I'm trying to get to, are produced when 2 moles of potassium phosphate react with 2 moles of aluminum nitrate. Now this is something different than anything we've seen before, so we're actually going to be looking at 2 different answers here and then comparing them. So in the first one, let's go ahead and look at 2 moles of potassium phosphate.
Mommy, can I hear your videos with you?
Yes, baby. Come on over here. So we've got 2 moles of potassium phosphate, and we want to see how many moles of potassium nitrate that would produce. So same thing we've been doing, we're going to drop moles of potassium phosphate down. And once again, we see a molar ratio here. So when we see that molar ratio, we are going to look up at the balanced chemical equation.
Okay.
Moles of K3PO4. I don't see a coefficient, so I'll make the assumption it's a 1. And then over here, I see a 3 in front of the potassium nitrate, so I'm going to put in a 3. That would give us a total of 6 moles of potassium nitrate. Now we're going to run through the exact same thing, except this time we are going to use 2 moles of aluminum nitrate. And let's go ahead and take a look at what that would look like. I've got my little helper here. Okay, so there's our 2 moles of aluminum nitrate, and we are still trying to get 2 moles of potassium nitrate. And this actually is alluding to excess and limiting reactants, so we'll actually be talking about this a little bit more on Thursday. We're going to drop down moles of aluminum nitrate. I am running out of room here, everyone, so kind of bear with me, please. Look to your coefficients. We see a coefficient of 1 in front of the aluminum nitrate, and in front of the potassium nitrate, we see a 3. So 6 moles of potassium nitrate would be produced regardless of how many moles we use, whether it's moles of potassium phosphate or 2 moles of aluminum nitrate. Sorry if it was distracting with my kids, you all.